Okay, so I finished up saying we were going to make very careful considerations about how I want my axes. The standard window, and I already have my function in here. If I just hit zoom 6, the standard window, and again my calculator is giving me issues, I got to remember to bring batteries. There's what I see for zoom 6, and that is not a particularly good graph. I see some stuff, but it certainly doesn't really show me the detail that I would like to see. Kind of hard to see what's going on over here. It's all close to that x-axis. So I'm going to give my machine better numbers. So thinking about better numbers, look at my x-axis. I really don't need much positive x-axis at all. And I only really need to go a little past -3. And then I look at my y-axis, and this is supposed to be y equals, not x equals. Y equals, again, I don't need much negative y-axis. So I'm going to do this. Not much positive x-axis. I think I said I didn't need negative x-axis. I meant to say I don't need much positive x-axis, and I don't need much negative x-axis, negative y-axis. And then counting appropriately, it looks like if I go -1, -2, -3, -4, that's going to work on my x-axis. And as far as my y-axis, if it looks like I go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, that's going to do everything I need to do over there. And so I think very carefully about what my axes should look like. What will be the best representation of my data? And that will be a good representation of my data. Now let's plot the points. We had -2.54 was a local max. So -2.54, maybe right about there. It's a max. 0, 0, that was a minimum. 0.341, 0.38. So maybe right about there or so. That was an inflection point, so we'll write IP by it. And then we had -0.58, 0.19, maybe right about there. And that was an inflection point. Now we're going to play connect the dots, working left to right. So we're going to go there, 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 there. You certainly don't have to number the points like that, but that's the order in which we're going to go through things. Now we have to get to the first point. That first point is not the beginning of the graph. The beginning of the graph is over here, but we got to get to it. So I look at my charts. Increasing, decreasing tells me I should start my curve by increasing, and I should be concave up. So the graph starts being increasing and concave up, and that tells me how to get to the first point. Increasing, concave up. I would accept anything that looks like that. That is increasing, because that's what this said to be, increasing, concave up. And now your points are going to guide you. This is an inflection point. The concavity must change. It's currently concave up. It needs to change to concave down. The curve is currently smiling. It needs to change to frowning. I go to the next point. It's a maximum. Well, draw it as a maximum. At a maximum, I have to go from increasing to decreasing. So I'll do that. It's easier to turn the paper sideways. Go to your next point. It's an inflection point. At inflection points, concavity changes. The curve is currently concave down. It must change to concave up. The curve is currently frowning. It must change to smiling. Go to the next point. It's a minimum. We'll draw it as a minimum. At a minimum, I have to change from increasing or from decreasing to increasing. And so something like that. And there's my curve. And it's very much like a puzzle. All the pieces have to fit together. And if you can get all the pieces to fit together, you almost certainly are right. But the nice thing about this is we can check it if my calculator behaves. Give the calculator approximately the same numbers we did. So I'm going to hit Window, and I'll go a little bit further than we did. I'm going to go -5 to 1, just a little bit further than we did. And we went to 0.6, so I think maybe I'm going to go from -0.1, say 0.7, and then we can count that off the same way we did by 0.1. Give the calculator basically the same numbers you did on your paper, hit Graph, and you should see something that looks similar. And indeed, we do. Those two graphs look similar. I feel perfect. Now, it's never going to be exactly the same, but all the big details should be there. It's increasing concave up, then it changes right about there to concave down. I hit a maximum, and it's all there. It looks the same, and so you're right. And if you really want to check the nitpicking details, that's what I wanted to say. Nitpicking details, do a trace. Trace, and we said that the local maximum was at -2, and so -2, enter, and it says -2.54, and that's what I said, and so it is right. These will check. And come test time, if you check it and it doesn't check, you write me a note saying this doesn't check. But if it does check, you know to feel very, very good about your work. And so there's our first full-fledged sketch. We'll do the next sketch. Lots of sketching in this section. Okay, next problem. Trigonometry. Sketch the following. Find the intervals where the function is increasing, decreasing, concave up, concave down. Find all local extremes and all inflection points. So we do the whole thing again. So increasing, decreasing stuff. So I need the first derivative. That x is not inside the radical. That is the square root of 3 times x. It is this coefficient times x. Doesn't matter if the coefficient's a square root, it's coefficient times x. The derivative of coefficient times x is just the coefficient. And then the derivative of 2 sine x would be 2 cosine x. Critical numbers. I set that equal to 0. And solve. Trig equation. Let's solve for the trig function. And I get cosine x equals negative square root of 3 over 2, which is going to give me x equals. And we are restricted to just the interval 0 to 2 pi. So I want to know where is cosine negative square root of 3 over 2 on the interval from 0 to 2 pi. And that's going to happen at 5 pi over 6 and 7 pi over 6. And again, I said this before, if you don't know those basic values, get yourself a unit circle and learn them. They are not going to go away. And we will just note here where f prime does not exist, is not applicable. Our derivative isn't a fraction, so I can't have some place where it does not exist. So then my increasing, decreasing chart. I'm only on the interval from 0 to 2 pi. So 0 to 5 pi over 6, 5 pi over 6, to 7 pi over 6, 7 pi over 6 to 2 pi. test values. Anything between 0 and 5 pi over 6, I'll pick pi over 2. Anything from 5 pi over 6 to 7 pi over 6, I'll pick pi. And anything from 7 pi over 6 to 2 pi, I'll pick 3 pi over 2. And again, if you're not familiar with the unit circle, get the unit circle. But now, in this one, truthfully, you could live without a unit circle, doing this part here at least. That you could change these two decimals. Now, you certainly aren't going to tell me answers with decimals in them. If I say, where is it increasing, decreasing, these are the numbers I'm going to see. But as far as completing your chart and then picking these values here, you could change these to decimals and then pick decimals in each place. It would work. Then I'm going to plug into the derivative. So the derivative's right here. So if I plug pi over 2 in there, cosine of pi over 2 is 0. 2 times 0 is 0. So I get 0 plus the square root of 3. That's going to be positive. Plug in pi there. Cosine of pi is -1. -1 times 2 is -2. Square root of 3 minus 2, I don't know exactly what it is, but square root of 3 is like 1.7. So square root of 3 minus 2, that's going to be negative. And then 3 pi over 2. So plug in 3 pi over 2. Cosine of 3 pi over 2 is 0. 2 times 0 is 0. Square root of 3 plus 0, square root of 3. So positive. And so we can say that f of x is increasing, decreasing, and increasing. Positive derivative means you're increasing. Negative derivative means you're decreasing. And now that we have seen those changes, I can say local max and min. That I'm going to have a local max on this first guy here, where the derivative changes from positive to negative, or the function itself changes from increasing to decreasing. I'm going to have a local max at x equal 5 pi over 6, y equal f of 5 pi over 6. And because we are graphing, I'm going to let you use decimals when we graph. So if I go into the original function here and plug into my original function, and I'm in the process of putting that into my calculator. If I plug that into my original function, and I did all my typing correctly, this comes up to be roughly 5.54. So I've got 5 pi over 6, 5.54 is my local max. Here I change from increasing to decreasing, or my first derivative changes from negative to positive, so I have to have a local minimum at x equals 7 pi over 6, y equal f of 7 pi over 6, and remember, y coordinates always come from the original, and so if you put 7 pi over 6 in there, you get roughly 5.35, and so 7 pi over 6, 5.35 looks to be my local minimum. And there's all my stuff about increasing, decreasing. On the next video, we will move to concavity.